Welcome to the deep dive. Today we're tackling what might just be the most profound question humanity has ever asked. Are we alone?
It's the big one.
It really is, and we're going to explore it through the concept of communication and this dazzling idea of an Encyclopaedia Galactica.
Right, and our sources start by acknowledging
Oh.
this deep human obsession with the question. We've sent 4 tiny probes out into the void, the pioneers, the voyagers,
Just dipping our toes in.
barely that. And despite all the talk, all the claims about UFOs and ancient astronauts, there's no compelling evidence of any visitation. The universe, for now, seems silent.
So our mission today isn't about looking back for visitors that probably weren't there. It's about looking forward.
Exactly.
If we get a message, what do we do? How do we even begin to decipher the knowledge of a civilization that could be millions of years ahead of us? And we're going to find some clues right here on Earth, in our own history. This is all about the search for extraterrestrial intelligence, or SETI.
And that desire to find a key, to unlock a completely alien culture. It's a powerful human drive. It doesn't matter if they're separated by 2,000 years or 200 light years. It's the same thrill.
And this is where history gives us such a perfect analogy. I mean, think about the great mystery of the 19th century, Egyptian hieroglyphics.
Secret carvings. For centuries, nobody had a clue. People came up with these wild theories.
Weren't there theories that the Egyptians were, colonists from China or something?
All sorts of things. The dominant idea was that the carvings were just pictorial metaphors, not a real language. And this all comes to a head in 1801. The physicist Joseph Fourier is showing his Egyptian collection to an 11-year-old kid.
Jean François Champollion.
That's the one. And the boy asks Fourier, what do these mean? And Fourier just says, nobody knows.
And for Champollion, that became a lifelong quest. The breakthrough, of course, was the Rosetta Stone.
Found in 1799. This one piece of rock was the key. Same message, but in 3 different scripts. You had the hieroglyphics nobody could read, then a cursive version called Demotic,
and Greek, the one everyone understood.
Exactly. The Greek text was a decree about Ptolemy V. So Champollion had the name Ptolemy in 3 different forms. He made this brilliant deductive leap. He saw these symbols surrounded by an oval.
The cartouche.
The cartouche, right. He reasoned that it had to signify a royal name. And if it was a name, it couldn't just be a picture. It had to be phonetic.
This is the key insight for SETI, isn't it? The realization that it's probably a mixed system.
It has to be. Champollion used the cartouches for Ptolemy and Cleopatra to match sounds. The square for P, the line for L. It was partly a simple substitution cipher.
But only partly.
Only partly. Because the end of the Ptolemy cartouche was pure picture. It meant ever-living, beloved of the god Ptah. So you had this hybrid of letters, syllables, and pictograms.
A palimpsest.
Precisely. A layered message. Simple elements mixed with rich, dense, symbolic language. And that is exactly what we should expect from an interstellar message.
So what we're really looking for is an interstellar Rosetta Stone. And if that's the case, what's the common language? What's the Greek of the cosmos?
It has to be science and mathematics. It's the one thing that's truly universal.
The laws of nature.
The laws of nature are the same everywhere. Gravity, quantum mechanics, the periodic table of elements. An advanced civilization would know that. They'd start there, maybe with, the first 10 prime numbers, something unmistakably artificial.
Okay, so they have a language. How do they send it? Not with slow-moving spacecraft.
No. The best way, the most obvious way, is radio astronomy.
It's fast, it's cheap.
And it travels at the speed of light. That's 10,000 times faster than our fastest ships. The sheer volume of data you can send is incredible. Take the Arecibo Observatory in Puerto Rico, that giant 305-meter dish.
Arecibo could transmit the entire Encyclopaedia Britannica to a nearby star in just a few weeks. The power of that is immense.
And the range. It could send a signal that's detectable halfway to the center of our galaxy. We're talking 15,000 light years. That capability, it just forces you to ask the question.
Is anyone listening? Or sending?
And that's where we have to turn to the cold logic of probability. We have to use the Drake equation.
Right, which gives us an estimate for N, the number of advanced radio-capable civilizations out there right now.
It's a product of 7 factors, and some we know pretty well.
Okay, let's run the numbers. So N star, the number of stars in the Milky Way, that's what, a few hundred billion? Let's say 400 billion.
A good starting point.
Okay.
Then FP, the fraction of stars with planets. We're now pretty confident that's at least 1/3.
Okay, so that's already about 130 billion planetary systems. Next up is NE, the number of worlds in a system that are suitable for life.
And suitable doesn't just mean a perfect Earth twin. We're talking rocky worlds, maybe moons with subsurface oceans, like Europa or Titan. So let's be conservative and say 2 per system.
Right, and then FL, the fraction of those worlds where life actually gets started.
This one's a bigger guess, but lab experiments show that the basic building blocks, amino acids, and so on, they form pretty easily under cosmic conditions. So let's say 1/3 of the time.
So if you multiply just those first four factors, the ones we're relatively sure about, the number you get is just, it's staggering.
It is. You get about 100 billion inhabited worlds in our galaxy alone.
100 billion. I mean, just stop and think about that. The galaxy is teeming with life.
It should be. But now we get to the really big uncertainties, the biological and, well, the sociological factors.
Fi, the fraction that develop intelligence, and Fc, the fraction of those that develop technology.
These are huge guesses, but let's be pretty pessimistic. Let's say only 1% of planets with life eventually reach a technical stage. So Fi times Fc equals 1 out of 100.
Even with that, you still get a billion planets where technology has existed at least once.
At least once. And this is where the entire equation hinges on the very last factor, F.
The lifetime of that civilization. The fraction of a planet's life that it has a technical civilization broadcasting into space.
And this is where astronomy stops and politics and sociology take over. It's really a question about us.
Because if a civilization develops radio technology and then, blows itself up a few decades later,
Which is a very real possibility. Nuclear war, climate collapse, you name it. Then that FL value is incredibly small. And N, the number of civilizations out there right now, could be as low as 10.
a handful, we'd be effectively alone in a vast cosmic graveyard.
But what if they survive? What if they make it through that dangerous technological adolescence?
If they take the proper fork in the road.
Exactly. If just 1% of technical civilizations survive for the long haul, then N isn't 10. It's in the millions. The sky should be softly humming with signals.
So the greatest unknown in the Drake equation isn't astronomy, it's us, it's human nature. Receiving a message would be the most hopeful sign possible. It would mean survival is achievable.
And that leads directly to the great contradiction, the Fermi paradox.
If there are millions of them, where is everybody?
Why the silence? Interstellar travel is slow, but it's not impossible. If the nearest one is a couple hundred light years away, they've had billions of years, they should be here.
To even start to answer that, we have to look at what happens when cultures with different technology levels actually meet. We have to use Earth as our lab.
And our sources give 2 very different prototypes. The first is a benign encounter. 1786, the French explorer La Pérouse meets the Tlingit people in Alaska.
The Tlingit had no rating, and they saw these giant ships as something from their mythology. They called them great black birds with immense white wings.
They were terrified at first, but the French were peaceful. They traded for iron. The Tlingit preserved a very accurate oral history of the meeting for generations. The technology gap was there, but it was manageable.
Okay, now contrast that with the ghastly prototype, Cortez and the Aztecs, 1521.
The Aztecs had incredible architecture, a complex calendar, a sophisticated society, but they were just a few centuries behind the Spanish in a couple of key areas.
Steel, horses, firearms.
That's all it took. Cortez, driven by what the Aztecs called an insatiable thirst for gold, completely destroyed their civilization. A few centuries of a tech gap led to utter annihilation.
So that's our fear, isn't it? If a few centuries made that difference, what would a gap of 1,000,000 years mean? We are projecting our own guilt, our own history onto the stars.
We have to be. We are afraid of them because we know what we would do in their place. A visiting civilization would be beyond us, as we are beyond a macaque monkey.
But then, if malevolence is the rule, they should have found us and destroyed us already.
Right. The fact that we're still here suggests that either they're benign or, more likely, we just haven't been found yet. And this leads to the colonization hypothesis.
The idea that any species that survives long enough for interstellar travel must have solved its own problems first.
Crucially, population growth. A civilization that keeps growing exponentially is trapped on its home world. You have to achieve sustainability first.
Zero population growth.
Or something very close to it. Then you can expand, but you do it slowly. Like a vine spreading carefully through the galaxy, only settling the best worlds. They wouldn't rush to every single star.
So if a civilization started expanding 1,000,000 years ago, 200 light years away, they wouldn't even be here yet.
They might have already colonized 200,000 worlds in their local neighborhood. Their slow, methodical survey ships might only just be stumbling into our quiet little solar system right now.
The age gap is It's almost impossible to comprehend. But their survival implies they mastered their own aggression.
You'd have to assume so. So physical contact. It seems unlikely for a very long time, but radio contact is much, much more probable.
And the search has barely begun. The sources say we're less than 0.1% of the way through a thorough search. And the cost? It's tiny. The price of a single naval destroyer could fund a massive systematic search.
So the ultimate prize, that palimpsest message, the announcement signal, then the primer, repeated over and over until we get it, and then the good stuff. Volume 3267 of the Encyclopaedia Galactica.
And the sources give us a little peek at what those entries might look like. Humanity is listed as a Type 1.0J civilization.
Characteristics: fossil fuels, nuclear weapons, organized warfare. With a survival probability of just 40%. The J probably stands for juvenile.
And that's contrasted with We Who Became One, a Tech 2.3 R civilization.
Ancient, interstellar. They use pulsars for power. Their survival probability is 99%. R might mean resilient, responsible.
That contrast says it all. The real dividing line between civilizations isn't their technology, it's whether they survive it.
Whether they authorize the search and whether they learn to manage themselves, that 99% survival rate, that's the goal.
Everything is at stake in this search. If we search for a century and find nothing, that silence tells us something profound about how precious and rare conscious life is. It would make every one of us infinitely valuable.
And if we succeed, the entire history of our species changes overnight. The knowledge in that encyclopedia would tell us how to become a Type 2.3R.
So we'll leave you with this thought. What specific technological and ethical traits define the difference between a fleeting Type 1.0J civilization and a resilient Type 2.3R? And looking at the world today, what category of civilization do you think we belong to?